Welcome back, class. Today we're going to look at how to create and evaluate an algebraic expression. So first we have a pattern, simple pattern with a number of circles. This is the term, and this is the term value. And we're going to put that into a table of values. So step one, we make our table of values. On the one side is the term number, and on the other side is the term value. So a little bit different when we're trying to make an algebraic expression because we're actually going to start at term 0. This is just a little trick in order to more easily come up with the algebraic expression. So in term 1, we have 3. In term 2, we have a value of 5. And in term 3, we have a value of 7. So if you look at the difference between each of the terms, it's going up by 2, which means if we were to go back to the first or back to the 0 term, the value would be 1. So those are the two most important numbers that you need. This 1 and this 2. So what you do is this 2 means it's going up by 2 each time, so we use that 2 to put it into an algebraic expression. So this is step 2, the algebraic expression. The 2 goes here, so we're multiplying the 2 times, we'll call this n. That'll be the variable that we use. So we can find any term number, so n means it could be anything. But we know we multiply it by 2. Now the last bit that we have to put on the end here is to do with this 1. So this 1 comes over here. Because it's a positive, we put the positive or plus addition symbol. And there we have our algebraic expression, 2n plus 1. Now, if we want to check, just to make sure that we've done this correctly, we can substitute one of the terms that we know into this algebraic expression. So this is us evaluating it. So 2, let's say we want to look at the third term. We put a 3 in, and then we do 2 times 3 plus 1, which is 7. So that's correct. We could check again. Let's put in the second term. 2 times 2 is 4, plus 1 is 5. So that's correct, and that's correct. So we know that we now have the correct algebraic expression. Now, the third step in evaluating it is you'll usually find the question says, find the value of, and it'll refer to the nth term. Okay, so what that means is it could be anything, the third, the fourth, the fifth, the sixth, the seventh, the 100th, anything. So all you're going to do is take the term number that you're looking for and put it in place of the n like we did here. So in this case, find the value of the nth term. Let's say a might be the 10th term, right? B might be the 100th term. So for a, we simply put the 10 in place of the n, right? Because our algebraic expression is 2n plus 1. And then we put the plus 1 here. 2 times 10 is 20, plus 1 is 21, right? So then we could say, therefore, shorthand for therefore, the 10th term value is 21. And of course, we'll just do B right here. Plus 1. 2 times 100 is 200. Plus 1, 201. So the 100th term is 201. So those are the steps that you need to go from the pattern to the table of values to the algebraic expression, checking to make sure we've done it properly, and then evaluating it for the nth term, which could be any term that you want to know. So rather than continuing down 4th, 5th, 6th, 7th, 8th, 9th, 10th, all the way to the 100th term, which would be ridiculous, we can just find it by putting in the number for the algebraic expression. And that's all there is to it.